Yeah, so hey, welcome. It's Thursday. We're back here with Shenzhen I. As you can see, I've got the uh, solitaire game pulled up. I'm try and clear the chat or something. Yeah, close it. Let's reopen Firebot. We got to do some tweeting out. Programming and designing stuff in Shenzhen I. All right, well that's booting up. What do we got? We got Shenzhen I.O. Zachtronics puzzle programming. Helps if I spell streaming right. All right, let's post that. Oh, I did not say I was live. Oh well. I'm live with okay, we're gonna post that. Boom. We got here. Oh, got some cool. Okay, got that out of the way. All right, so yeah, so we're rolling with the good stuff here. Nice little solitaire. Was just getting into the groove of things. So we're gonna get back to it. Where did my Firebot go? Okay. I think we go through the mail. Yeah. All right. Let's see. Dear adventurer, take an orbital selfie. Experience the stars and Earth as you have never seen them before. The JSC Space Adventures Moscow. That sounds fun. So from Joe, it begins. I got us an incredible deal with a major esports personality, the Solid Steel Gamer. Her team's contracted with us to make light-up signs that actually animate for her fans. As long as we keep the cost down, they're going to want tons of these. Looks simple, just a few states. Well, let's figure it out. Build in some light-up signs. Is my volume going nuts again? Hello? Yeah, it sounds like it's going to hello. Okay, that seems better. Probably a little quiet, but better than breaking it. Okay, so we've got this whole shape. So I didn't talk about this last time, but this is like the designer mode. So what we got here is we have kind of like the product shape itself, and then we have these ports. They all have like different purposes and stuff, and so we'll see. Click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0 and drink 1 and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Control the display segments with fixed repeating signals as indicated in the verification tab. Yeah, so basically we just want to match these, which is actually cool because what we can do is if we wire up, we do this, I think this is our cheapest programmable component. So if we move 100 into the accumulator, yeah, it's like tough. So I think what I'm going to do is I'm going to do not, which will change the accumulator to 100. And then we can move the accumulator to P0, which is not wired up. So we're going to wire that up to click 0. And P1, we're going to wire up to click 1. So we're going to move that, then we're going to do not, and we're going to move the accumulator to P1. So it's 0 to 100. We write 100 out to 0. But then we want to flip it. So we need to put a not there. And then we'll sleep 1. And so that should be, I think that should be good there. What is the... I don't think there's... Yeah. Alright, so that's our click. You can see the little finger clicking. That's our finger clicker. And that works, yeah. That gets us moving. That's exactly what we need. Alright, so for drink 0, we got a couple of different things going on here. So these are all... Well, they're not too different. Yeah, they're not too different. We just have... well, actually, I can't wire 3 ports to this thing, so I have to use one of these. Because this has 3 pin inputs on it. Does it? It does not. Okay. So I guess I need to use 2 of these. Yeah, so this is where the fun comes in, trying to fit all these pins here. So this one, we need to move it, so that, ooh, yeah. This is also a spatial puzzle. It's not just programming, it's a spatial puzzle. So we need pin 0 to come out, and we'll wire it to drink 0, and we'll do pin 1 to drink 1. Right, that should be fine. And then that leaves pin 1 here, can come over here, which I guess, actually you can move down there, can't you? And then we don't need you so far away. Could you come like right there? That goes like that. Yeah, that seems more reasonable. Okay, so drink 2 is our, what are we sleeping for? 1, 2, 3, 4, 5, 6, 7. So we're going to move 0 to P1, sleep 7, move 100 to P1, which I forgot to type the P1 there. And we're going to sleep 2, right? That should do it. Where did Firebot go? Hey, Katana. Welcome back. With an @ sign for some reason. Okay. If we advance this, we should... Yeah, we do have drink 2. Ooh, no, that's not good. That is 7, and then there must be 8 sleeps here. Yeah, so okay. So sleep 7 only happens the first time. So we're gonna sleep 7. We're gonna like mark that loop, and then we'll just jump loop. Because that needs to be 8. Ooh, wait. So we sleep 7, and then we're jumping straight in to sleeping 2. Then we move 0 to P1, and that's when we sleep 8. So we come in. Okay, that gets us going. Which means they're all going to have to like be offset by 1, which is really frustrating. Yeah, what is this gap? This is 3, 4, 5, 6. 3, 4, 5, 6. No, that's 6. That's 4. So it's just this first one that's got an extra gap in it for some reason. That is annoying. Okay. All right, so anyways, what we have is we have a drink 0. So we're going to move 100 to P0. That's our drink 0. And we're going to sleep. Oh, and then we're going to move 0 to P1. And we're going to sleep for 6 steps. That'll get us here, where we move 0 to P1. No, to P0. And then we sleep. We only need to sleep for 4. So we move 100 to P1. Sleep 1. Move 0 to P1. Sleep 2. I'm out of code. No. That means I have to pull out the big guns. Where I need to move you this way. Yeah, that's fine. We just have more lines of code that we need. Okay. Don't really like that. What is this thing? Oh, it's a note block. That lets you type stuff. Cost 0. Just let you take notes. Okay, so we sleep 2. Move 100 to P1. Sleep 1. And then we're back to the top. Then we're back to the top. That should cover all of our needs. Yeah, so let's simulate that. And then you can see our little sign. Drinking. And clicking away. Yeah. Oh, there's a simulation speed. I should probably increase that. Lines of code is pretty average. We can do it with a lot less, but I don't know if I'm going to be creative enough for that. It only costs 11 yen? What? Oh. I mean, it's pretty cheap. I don't think, I mean, like, what is the same here? We got this one. Sleeps for 6. Then it goes off for 1. I wonder if we wire it up differently, right? Let's try and make another solution. So if we go back to our concept mail, we'll come back to that. Let's actually, I want to copy that solution. Yeah, so I'm going to delete that one. All right, so we want to keep that, but we want to bring this out. So which ones are similar? These are kind of, well, these are kind of similar, honestly. So like drink 0 kind of on its own. So if we put drink 0 by itself, like right there. Drink 0 is move 100 P1, sleep 6, move 0 P1, sleep 4. That's basically it. I have a wire here. I have a note node. Can I pull some of this off into it? Ooh. What did I do there? No, I can't copy and paste. Okay. Well, that's fine. Okay, then this one will be wired to drink 1 and 2. Because we're going to sleep for... We're going to sleep for 6. Move 100 to drink 1. So that's P0. Sleep 1. Move 0 P0. Move 1 P1. Move 100 P1. Sleep 2. And then it needs to swap again, right? Yeah, it's basically like swapping which one's which. And then move 0. Yeah, I don't have enough code on there. I don't have enough code. I don't know that it's going to be any smaller, though. I don't know that it's going to be any smaller. If we put that there, and we get rid of this component, and bring this one in, then we got that there. So move 0 to P1, which is our drink 1, no, our drink 2, and move 100 to P0. sleep 1, move 0 to P0, and then we start over. So that does seem to work. Well, that was 2 lines of code less. Wow. We didn't save a whole lot of power. Did we go up? Yeah, we went up. We used more power. And it's the same cost, so yeah, we didn't save anything. Okay, the end result looks great. I love the way it looks like the Solid Steel Gamer's really clicking through. Yeah, this is gonna be huge. Sure is. All right, what do we got? Drinking game scorekeeper. The Baron von Schnaps is in the house, y'all. I was out drinking last night. Met someone from the company that owns this brand. There's a drinking game. What game? What counts points? I don't remember the actual rules. He doesn't remember the rules, but we're going to build a scoring system for it. Okay, so we have this really cool component here that has a digital number. So point and foul are simple inputs connected to buttons. Display is an X-bus display output corresponding to a numeric LCD screen. The counter should keep track of a count starting at 0 and ensure that the display is always showing the current value. When point is pushed, the count should be incremented by 1. When foul is pushed, the count should be decremented by 2, but not below 0. Okay. Pretty straightforward. I think we're going to have to read the specs on this one. So let's hop around, do some shuffling, turn this on. What do we got? Pop it open. Let's look at... do we have anything in here for LCD displays? Yeah, we got the parts. That kind of explains some of how the parts work. I think XBus is just for sending data. It's nothing special. You just can't write to a port with it. Yeah, read-write XBuses. This is a pin node at any given... What is this? The digital I/O expander? What is that supposed to do? Control the world with the DX300 digital I/O expander. This unique and useful part can read or write up to 3 on-off signals at once. It is sure to find the ideal application in answering many of your control. Okay, so like you read right in here, and then I guess this is set. A stepper motor control. So move 110 to X3 goes in there. Oh, it's like 110, right? And then the motor's on. And then 011. Yeah, it's like binary. It's like binary. We can write 3 different things, can write into it. That's pretty cool. That's pretty cool. That's pretty cool. Random access memory. Ooh, yeah, we get some RAM components later. Cool stuff. Circuit data packet. All right, but we're looking for like an LCD screen. Okay, you know what? I think we'll just figure it out the hard way. So it's an XBus, right? So we're just gonna move 100 to X1. Do it. Does that read 100? That part's not sleeping, so like then sleep for like 10 or something. So boom, that's... In what way is that 100? What is this component supposed to look like? Goodness gracious. Like I think we read it. We have to read it from the bottom, I guess. Well, anyways, we are gonna have to do some conditions, so I'm almost positive that we will need. We'll need this. We don't really reset it, so I guess we'll start. We'll start from 0, really. So we just wire point up to 0. Well, I guess point will go to pin 1. And that will go to pin 0. So we'll check them out. What is the input going to look like when we get to, wow, it's 100. Yeah. All right, so we're going to copy, we don't even need to copy. Test equal P1 100. So if P1 is 100, which is the point value, we will add 1. We need to add 1. And then if we're going to test equal P0 is that 100, that's our foul, we're going to sub 2. So subtract 2 from the score. And then after every one, we'll write it out. All right, so we'll move ACC X3 and we'll sleep 1, right? Oh, you know what? But we didn't do TLT 0 ACC. So we'll move 0 into ACC. Yeah. Our score's incrementing. Yep. All right, let's go for it. Lines of code is good. Looks like it's pretty low. Our cost is high, but I think that's because we do we actually have enough code to fit on? We do. We have enough code to fit there. Which means that I can go oh, no, that's X2. Wait, what is this? These are all X's. There we go. There we go. Okay. Yeah, that's a X variant that doesn't need pins. X3, we need to do just X1, I think. So yeah, that works. So that part is 2 yen cheaper. Or, I mean, it's yen. I don't know. Like, we're in China, but that's a yen sign. I don't know how to save power. That's interesting. Oh, I didn't mean to click continue editing. Yeah, all right. If you can't remember the rules of the game, how did you make the deal? He just made the deal. Y'all, y'all. All right, take for a totally random example. Shenzhen, how do you say it? What's the ZH? Can you ignore the H? Spoiler warning, you can't. ZH is its own sound in Chinese. We don't have time to go into all the fun foibles opinion. The official romanization system. I'll do one more. The Chinese it's yuan. One syllable. Yuan. How about trying to say yuan really, really fast? Yuan. You're still making 2 sounds instead of 1, but maybe it's closer. Maybe. Ooh, that's tough. Yeah, so that's Chinese yuan. I didn't know they used the same symbol as yen. That's interesting. Oh, yeah, they call it out here. By the way, we use the same, which you might be associated with Japanese yen. And it is. It's also Chinese yuan. Cool. Learning stuff. Oh, dang it. I left the thing open. You missed all of the fun coding in that last challenge, and you missed all the well, that's fine. You didn't really miss a whole lot. What am I saying? Psh. What do we got? rubbish audio thing. All right, so contract comes to deliver a piece of audio kit. Sounds fun, right? I've always liked audio. We should mention and put a copy of said advert on your desk. We still have to do this, as sad as it is. Okay, well, it doesn't sound sad. Hey, at Alexi. All right, let's open a new design. Okay, we got to maximize. So audio in is a simple input connected to an audio source. Audio out is a simple output connected to an audio source. Maximize is a simple input connected to a switch. The signal from audio in should be copied to audio out, applying the harmonic maximization algorithm when the maximize switch is on. Look in the supplemental data section of the manual to find an advertisement featuring the harmonic maximization algorithm. Okay, what is the harmonic maximization algorithm? Supplemental material. Math coprocessor. Interesting. I'm looking for an advertisement. What the heck? I can't read that. It's in Chinese. What is all this nonsense? It's like some kind of circuit diagram. Oh, is this how... This must be just some fun bits. Okay, here we go. Supplemental data section. Incredible sound. The audio out is equal to the audio in minus 50 times 4 plus 50. Yeah, we could read the whole thing, but, audio in minus 50 times 4 plus 50. Before I go and do anything, I did not turn the... Okay. There you go. Now you can see in the manual, we got the audio in, we got the advertisement there. Okay, I'm going to turn it off before I write code now. We got the algorithm. I got it pulled up somewhere. Let's see. We need to, we got this audio in signal. So first, let's get a copy in. Really. So here's what I'm thinking I'm gonna do. We're gonna do audio in is gonna go into pin 0, maximize. Ooh, we need another pin, don't we? I think you only have 2 pins on you anyways, too, don't you? P0 and P1, yeah. And you got 4 X's. Interesting. That lets me connect wires over, like I can do that kind of stuff. That's what that's for. And it doesn't cost anything. It's just a little design tool. Okay, so I'm definitely going to have to use 2 components. Unfortunately. Which is, it's not that bad. So we'll wire those together. I do need both pins over here. So we need audio to come in, and we need maximize to come in. And then I need to be able to write to it. Okay, so the first thing we're going to do is we're going to do our maximization. This is really just going to, move X0 to P1. Sleep 1. Actually, we can just SLX X0. Yeah, we got the X there. This one can... so we're going to copy P0. No, we don't have copy. Move P0 to the accumulator. Then we're going to test equals 100 P1. So if it is, what do we have to do? We have to subtract 50. So we sub 50 mul 4 add 50. And then we're going to move accumulator to X1 and we're going to sleep for 1. All right, so we should be sending our signals through. Then we get our maximize boost and we start writing our harmonic maximization blar, I don't know. Harmonic maximization something or another. Bam, lines of code. 9 lines of code. Hey, I did pretty good there. Power usage is low. And we spent 6 yen. That's pretty good. Pretty good. I'm happy with that. That was a good run. This thing is awesome. I hooked up one of these babies to my stereo at home and it blew the speakers clear off. I don't know if that's awesome. Like, is that really what you want your audio device to do, is blow your speakers up? Self-driving car stuck in a loop? What year is this? If you bought a self-driving car in the past 5 years and your car was involved in a rogue loop incident, you might be entitled to compensation under a settlement to a class action lawsuit. Talk about spam mail. I get spam mail in a game. Come on. I'm in the process of setting up closer tie-ups with the top global firms, and I'm working to secure higher profile work for our company. The first result of these efforts is a contract to create an infrared sensor. Cool. This allows us to participate in the booming market for passive monitoring. So we don't have to make fake cameras that just blink lights. Okay, we got this RTC thing over here. Okay, we can flip it around. We got some kind of timer. Tick time. On time, off time. Interesting. Time is a simple input connected to a DT2415 time. Where's time? Connected to a DT2415 clock providing the current time. Sensor is a simple input connected to an infrared sensor right there. Alarm is a simple input connected to a silent alarm. When the current time equals the on time, the device should be armed. When the current time equals the off time, the device should be disarmed. Whenever the device is armed and the sensor reads at or above a value of 20, the alarm output should be active. Is that time? Is that what this is? Is that a timer? It's got a looks like a battery case with it. Let's see if the manual has anything to say about it. So we'll hop over here. We'll turn the manual on and we'll look at the manual. And I will do my darndest to turn it back off. This is our carbine target illuminator. I guess we're going to build weapons. That's interesting. Yeah. Well, we got some signal stuff. We got some... Is that a machine gun? No, that's an arm. Okay. Nothing about the RTC machinery. Yeah, right here. Denver timekeeping. The DT 2014 2415 incremental clock. Do I have that component like available to me at all? Or is it just like all of these numbers? Yeah. It'll be cool when I get to like use more stuff. Okay, so like time between 0 and 14. Okay, so this emits a simple I/O signal that corresponds to the number of 15-minute increments since midnight. Wow. It includes a built-in backup battery, so the time is kept. Okay, so between 0 and 14 minutes after midnight is 0. Between 15 and 29 is 1. I guess this is 93 15-minute intervals. Up to 95. Yeah, okay. Yeah, I mean, that works. That's a way to do it. Whenever the device is armed and the sensor reads at or above a value of 20, the alarm output should be active. So I feel like we'll probably have you be the armed. We're going to put a bridge there so we can pull the time out. And then we need, where's our X variant? Like right there, part not recommended. I need to read multiple X values. I guess I need that. I mean, why is that not recommended? I know it's not recommended, but I'm going to use it. It is cheaper than this. So even though they don't recommend it, I am using it. I think I'm going to put this like on time in x0, off time. Wire that up there into x3. Shoot, where does that go? That's a simple IO. Does that need to go into a P? Does that need to go into, yeah, that needs to go into a P. Okay. Okay. Good gracious. So that's like arming and unarming. That's kind of like its own thing, right? And then, but I need the time down here. I need the time down there. And I need it to be able to communicate with other things. So we are just going to have to use the big boy. Okay, so we'll do x3, I guess. We'll go up here. And then we still need our bridge. Pop that in there. Whoop. And yeah, I guess we'll move the bridge. So we could do that. And then that'll bridge those. Okay, these go to X. Interesting. Okay, so we need to tell it to arm. Right? We need to tell it to arm. So this doesn't really need to do anything until it arms. So we can sleep X until X1. So until it arms. And then once it's armed, or we'll move X1 into accumulator. If accumulator is, we just do 1, right? 100's fine. And we're gonna we're gonna call it armed. I still think we need, okay, right? If it's 100, right? If it's armed, you know what? We sleep there, armed loop, right? So this is gonna test if test greater than P0 is if it's greater than 19, right? Then we need a sensor, so we need to move 100 P1. We should probably move over to verification. And then that's gonna sleep 1, and then jump armed loop. I guess we're gonna move so X3, dang it. See, this is where I get confused, because I want a flag that says, hey, it's armed. How do I do a flag this way? Are you kidding me? I said I wasn't going to do it. Oh my gosh. I need like some kind of buzzer that's like, browser's open. All right, so basically what we're going to do is we want to handle the time. Let's do that. Let's do the easier part here. So we're going to pull in the time. I guess every tick. Yeah, it looks like the time goes up, and then down. So I guess each one of these is 15 minutes. Well, I mean, can we see? Why can't we? Is it because I don't have code? Oh, what are you doing over there? All right, so time is 84, 85, 86, 87. Okay, wow. Oh, so each of these ticks is a 15-minute. Ooh, okay. So we're going to test equal on x0 to p1. If that is true, then we're going to arm it. So we're going to move 1 x3, right? But I mean, we've got to basically keep moving every time, right? Like move 1 x3. We're just gonna do it this way, and we'll figure it out. Okay, and then we'll test equal x0 p1. It's x1. We're gonna move 0 to x3, and we're gonna sleep 1. So little code. Okay. So basically, right here, what I want to do is I only want to read from x1 when I need to, right? So boom, 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 boom. So that sends a 1. And then this one needs to read the 1. But I don't want this one to have to run all the time. Right? Like, why does this need to run all the time until it's activated? But then if this is reading... So I guess we'll do sleep x1, move x1 to the accumulator. Yeah. So you don't block it. So we hit 93, and that sends a signal. And then we keep going until we hit 38. 38. So there's no signal there. So I guess, oh, you know what? I think there's a test command. I'm not gonna fall in the trap and open the flipping browser again. I think there is a test command like TCP. Where's the language reference? Give me the test instructions. TCP, compare the value of the first operand to the second. That is not it. TLT, TQ. Okay. So SLX is like sleep until data is available to be read on the X bus. So it doesn't look like we have the ability to detect a read. Yeah, it doesn't look like we have the ability to detect a read. This is where this thing would come in handy, but like I'm not allowed to use that component yet. So I guess I gotta solve it the terrible way, which stinks, but I mean, I guess it is what it is. Yeah. Sleep until data is available. I don't want to sleep until data is available because I got to do stuff. So this is going to have to run like every... Shoot. This is going to move 100 into the accumulator. This will move 0 into the accumulator. This will move the accumulator to x3. This will sleep for x1 to be written. I mean, it's gonna be a sleep one anyways, because it's gonna write to it. So sleep until x1 is available. Test if x1 is 100. Test equal p0. No, test greater than p0 19. And then that changes the value of plus. That's weird. That's weird. It's weird. We're gonna move 100 to P1 to the alarm. and then we're done, really. Yeah, like that's just gonna keep writing like values. So that's writing 100. That is alarming constantly. Why is that alarming constantly? P0 is greater than 19. Oh, yeah. Move 0 to P1. Yeah, do that. Yeah, there we go. Okay. Ugh. I kept trying to do like a flag flip, but it just didn't work. It just wasn't working. I mean, that's a pretty efficient solution, though. Like, 8 better and power is way less. I mean, that's a win. That's a win in my book. That's a win in my book. Okay, what do we got? We got just letting you know that your design for the infrared sensor component was well received. That's good. Hang on, we're becoming a defense supplier? Is this where we get into the weapons and stuff? So they're working remotely. That's weird. I thought you got back from your trip yesterday. I did, but I've been stuck in traffic jam on the way back from the airport. Since yesterday? There might be some strain. Stuck in traffic for more than 24 hours is not growing pains. That's something is wrong. Goodness gracious. Virtual reality buzzer. Create a working design for this product to view histograms and leaderboards. But I've met this wonderful girl named Xiaomei, and well, to make a long story short, she's set to move in with me next month. Okay, what does that have to do with this? See, when I'm doing my VR sessions, it's easy for someone to sneak up on me because I can't see or hear them. Okay. A simple vibrating buzzer that attaches to the VR headset so it can be left even during the most intense sequences. Connecting that to a radio controller. Okay. Normally, reading XBus causes the microcontroller to block until data becomes available. However, this radio has a non-blocking XBus buffer. The non-blocking buffer will immediately return a value of -999 when no data is currently available. Yeah, why not? All right, so that's this thing here. So we got an RX and a TX, some kind of antenna. Probably going to have to write to it. I guess I need to go to right there. There we go. Okay, we got the Chennai Com solution. Convenient pin locations. So this is receive and transmit. We transmit and receive pins located in the same side of the part. You will never find yourself moving components in an awkward way. Yeah. Okay, so radio RX right there is a non-blocking XBus input. Buzzer is a simple output. When the data packet is received over the radio, read it and execute the corresponding command in the following table. So if 0 is received, power off. If 1 is received, power on. Oh, so power on, we buzz every second. Buzz, 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 and then when we power off, we don't buzz. Okay, so there's a little attachment. All right, so we just need like a bloober. Come on, we're going to pop you over there, and then this is an X-bus, so we go straight there. So yeah, when we receive a 1, so we'll test equal x0 to 1. If that's a 1, we need to start buzzing. How do we start buzzing exactly? So if it's a 1, we receive a 1 on only 1 frame. So we need a way to start buzzing. Can I access the data? Can I access the data? The data? Where's my data register? You gonna tell me about registers? Registers. Registers. Yeah, DAT is the second register available on some. Yeah. So feels like probably you. Yeah. So we've got DAT. So if we test equal x0, if it's equal to 1, we're gonna move 1 to DAT. Otherwise, we're gonna. No, we have to test equal x0. Test equal x0 to 0. We're gonna move 0 to DAT. And the reason why we need DAT is basically so we can do our so we're gonna test equal DAT to 1. So if our DAT is 1, we're going to move 100 to the accumulator because we start on, right? So we're going to move the accumulator to P1. We're going to knot it. And we're going to sleep 1. And then if it's equal to 0, we move 0 to P1 too. It is sleeping. It should always sleep. What's going on? So we don't get anything. Here we go. We didn't get anything. Okay, wait. We got the 1. How did I not read the 1? Test x0 is equal to 1. Move 1 to DAT. Move 100 to accumulator. And why are you positive 2? Goodness gracious. I guess that has to go there. Yeah, that has to go there. All right, so we move 1 to DAT, we move 100 to the accumulator, then we correctly skip that, we test that, we move the accumulator out, and we sleep. And we are buzzing. And we got... Whoa, we got a 0. Ah, shoot. We got a 0, man. We got a 0. We can't do test equal here. Which means we can't do DAT, right? Because we need an accumulator. Yeah, I think we're going to have to do our reading and writing in a different node. Yeah. So you can just go there. So yeah, you're basically, you're going to move. What even are you called? X0? We're going to move X0 into our accumulator. The reason why we've got to do this is because when we read the value to do the first equals, it's gone. So the second, it'll never be 0. We'll never trigger the 0. But we're using accumulator and we're using DAT, so that's what we got. That's what we got. Anyways, so move 0 to the accumulator. Move 0 to the accumulator. Test is equal. Test equal. I'm going to have to write a bunch of random stuff. Okay, so if the accumulator is equal to 1, then we want to move 1 to P1. Right? Move, I guess, move 100 to P1. I don't know. We'll figure something out. No, I'm just X1, right? Move 1 to X1. Otherwise, we're going to test accumulator is equal to 0. Move 0 to X1. We really will only write those out, and then we just kind of sleep 1. So then we can bring U in. That's annoying. There we go. Hello, hello. Yeah, I know it's not connected. I'm trying to connect it. X1 to X1. Okay, so we've got X1. We got X0. And we got X1, right? That's our trigger. It's not going to come in every frame, though. See, that's the thing. It's not going to come in every frame. I do kind of need a signal every frame, don't I? So then I need to swap these two. Like this needs to go here. Yeah. And then you go there. And we can't go out X1 anymore, so we're going to have to do like X3. And let's go ahead and wire X3 up. We wire that pin up. X3 goes to X0. Okay. So this will move 100 into dat. And this will move 0 into dat. And then we'll move dat to X3. That way you can always act off of it. So we only need to test equal if X3 is equal to 1. If X3 is equal to 1, we're going to do our stuff. We're going to move accumulator. No, if X0 is equal to 1. So we'll move into the accumulator. This should be fine. Okay, so if it's X1, we're going to do not. We're going to move the accumulator to P1. That'll get our 100 out. That'll get our 100 out. If it is not equal to 1, it's got to be a 0 because we're only doing 0s or 1s. Then we can move 0 into the accumulator. Move 0 to P1. And then we can just sleep until, actually we can put that up there. Sleep until X0 can be read. Should work. Yes, okay. Whew. A little frustrating. Lines of codes are smaller. Power's smaller. Best is 444, now 420. Okay, yeah, and price is the same. Somebody did it cheaper. That's a tough one. I'm sure I could have done it cheaper with like a flag. Like one of these would be sufficient. Like 2 little guys, that's 1 plus 6. 1 plus 6, really? Seems sufficient to me. What do we have now? 5, 6, 7, 8. Yeah. 2 of these, 6, 7. Yeah, that's $1 cheaper. It's not a lot. It's not a lot, but it's saving money. Saving. Yuan. He's exactly what he imagined. Cool. Prototyping. Sometimes a decent product idea falls out when you're faffing about with chips. We can test with some different parts too, such as custom LCD panels. Custom LCDs? Are you serious? That's brilliant. We could make a retro-style handheld games. Let's all take turns designing one. Design and create an electronic game. Ooh, okay. So this is like a freeform level. Yeah. Wait, so where's my LCD at? Oh, I have access to everything. Wow. What is that thing? Like a... Is that the button? So where's the LCD? That's what I want to know. There we go. Boom. So if we look at the manual here, it's got to have LCDs in here somewhere. I think it does. Is that what this page is? The Ink Smart Die Color Space. Is that what this is? LX700? LX700. I don't think that's covered. LX700, where are you? Oh, here we go. The Lux Industry LX910C. That's this one. Oh, this is a numeric display. 7-segment numeric display. This is, to add a custom screen to the sandbox, create a grayscale image that is exactly 320 by 405 pixels, using black for segments and white for empty space. Save it as a PNG in the custom screens folder of your Shenzhen I save. Restart the game, select your new screen pattern from the list of custom screen patterns by clicking on the pattern name displayed below. Look for the Parts Plus catalog in your manual. Yeah, so we've got segments. How do you number segments? That's crazy. Ah, there we go. Is that how we do it? Right value segment. So this segment, turn on segment. Negative segment, turn on all segments, turn off segments. Oh, there's a segment touch event for real? So this is cool, but I don't know that I have an idea. I don't know that I have an idea for how this would go, like for a game right now, off the top of my head. But I mean, we could pretty much do whatever we wanted, I imagine. So T0, what is CN? So the CN ones are touch and release. So if we go here, right, we've got like segment 1. So if we do up to 120, so we'll do accumulators. So we'll add 1, right? We'll move accumulator to x1, and then we'll test equal test equal the accumulator. If it's 120, which is the last segment that we've got, we're going to move negative 121 into the accumulator. And that'll basically reverse it. Sleep 1. Yeah. So, boom, 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 boom. Yep. And then if we simulate that at some speed, we've got a thing. And there it goes. Isn't it amazing? It's so amazing. That's a game, folks. That's a game. Right there. I mean, we could do something like we got buttons, right? I think. Is this a button? Do I wire it up that way? So if I run the simulation and like so that's a button. That could be like a left or right. So we could do something silly like if we have a width of 3, let's just pull out the big code, because like price doesn't really matter. Let's pull out the big coder, the big boy coder. We're gonna put that there. We need a bridge. That's gonna go in there. And then I guess I have another button. Can't just like copy and paste a button, you know. We're gonna go up here, and we can run this button to. Do these go to P? I guess it doesn't matter. Okay, so we have a width of 3, so we'll put our position. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 actually. So like 3. So we'll put our starting position, move 114 into dat, and then we'll mark our loop there. So that's just like our starting position. So then if test equal P0 is 100, we'll sub 1 dat. Ooh, we need to do that in the accumulator, don't we? Accumulator sub 1, and then we want to test equal P1 100. We'll add 1. We need to check, so we have 118 to 111, so like TLT 111. If it's less than 111, accumulator is less than 111, then move 111 into the accumulator. I think I just saw something happen. Maybe it was on the screen. Oh, an ad break ran. Well, sorry folks. I need to set a timer for that. Okay, so we're just messing around with this. We're gonna make a little moving thing, and then we'll move on. If it's greater than 118, the accumulator 118. Oh, I had that right. Okay. Then we want to move 118 into the accumulator. Now we need to render the segment. So we're going to move. Oh, shoot. Sub 1. Dang. See, this is the hard part, because now we need another piece to render, which is fine. We can do whatever we want. We're not restrained here. So that's fine. We're going to put that there. So you'll just move over. You'll move over the current. Move over accumulator to X3. And then you'll sleep 1. And then over here, what we'll have is our accumulator value. We'll move X0 into the accumulator. So I guess the first thing that we'll do is we'll move the accumulator into DAT. So we'll copy its value. Oh, do we even care, actually? I don't think we care. No, we don't care. So we're going to erase our current position, move. We're going to move. Oh, we need to connect it up, don't we? To there. Okay, so we're going to move. So I guess mole -1. Move accumulator to X3. Sub 1, right? 113, and I want to go to -114. So I guess sub 1. Move accumulator to X3. Sub 1. Move accumulator to X3. Then we're going to move X0 to the accumulator. That's our new position. And we're going to move the accumulator to X3, add 1, move accumulator to X3, add 1, move accumulator to X3, move accumulator to X3, and then we're going to sub 2. Right, so if 114 comes in, we add 1, -2, we're back to 114. Just in time to sleep. We'll sleep. We'll sleep 1. Sleep 1. Yeah, that's fine. And you'll go ahead and move accumulator to X3. Yeah, just get that over with. So, move. So I guess what we need to do is instead of that, we're going to move X0 into DAT. Then we do the accumulator thing. Then we need to move DAT to the accumulator. So we get a negative, we subtract, move to the accumulator, sub 2. Why is that doing that? What are we writing? We're writing 0, which doesn't do anything. Then we subtract -1. Goodness gracious, we need to subtract 1. Yeah, so that sends that signal. What the heck? Move the accumulator. Okay, so move 114 X3. Move 114 into the accumulator. Gosh darn it. All right, so we have our thing there. Wait. Oh, I guess we don't need to sleep, do we? What the heck? So x0, I guess. Okay, so here we are rendering. So if we press why is that not saving? Okay, what do we got here? Oh, jump loop. There we go. Okay. Okay, well, our racing is not working. That seems to be... Yeah, like, that's not showing us anything. So if we pause it and we step through... Why does it send 118 over? I think I have to get to the point where I'm reading from it. So, yeah. When I read from it, I guess actually I want to put this SLX at the top. Like it should fire immediately, right? I don't think that's going to change anything. But we get 114. We undo. Then we render. Then we wait, and it sends us 114 again. So we undo, and we redraw. Why didn't we undo everything? We're missing another. See, this is that thing. This is the thing. Can I send a signal to two nodes at the same time? I don't think so. I don't think so. That doesn't need to store the position though. So we just need a signal to go here that says we need to erase it. We need to erase it, so X3 needs to go there. So we need to erase it from... Oh, we need to know the last position. Yeah. So we've got that and dat. We do that, move accumulator X3. Then we move dat accumulator, move dat X2. And then we're done. We have redrawn, so we need to move this here. Here. That way X2, gosh darn it. I can't get in there. Move that over. We move that over, then I can definitely get X2 to X3, and I can get X2 up into there. Hopefully I can write multiple things into it. Okay, so that goes over X2. So now we will SLX X3. That's going to be our new value to draw. All this one needs to do is draw it. So I just simply draw it, really. It's in the accumulator. So we'll move x3 into the accumulator. We'll move the accumulator to x2. We will add 1, move the accumulator to x2, add 1, move the accumulator to x2. Just like that. Okay, now we got all this stuff moving. There we go. There we go. That's what I'm talking about. Now we've got like a little bit of a game going. Right? Okay. See? All of that work. We got all these components, and now we got left and right buttons where we can move a little thing across the screen. And in theory, we could implement some like, physics, like bouncing, do some kind of a brick breaker scenario. So we'll need, we'd need like a big old random access memory piece. I'm assuming this is a RAM piece, 100p33. Where are you at? 100p33. 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 What is this thing? The simple I/O logic gate family offers a bit of extra logic you've been wanting for not a lot of money. Ooh, and an OR gates. Cool, cool, cool. Input A. OG04. Yeah, so those are our logic bits. Anyways, what do we got? We got random access memory. This component here, we've got A's. All memory cells initialize to a value of 0. All memory pointers initialize to point at the first memory cell address 0. Memory pointers can be read and written over X bus with the A0 and A1 address pins. So those are read and written. Memory values referenced by pointers can be read and written over X bus with D0 and D1. What does pointers mean? Write to memory. Move 0 to X3. X3 goes to A0. Move X0. How do we read a specific value? I'm curious, like, how does that work? So we got a little example setup here. We got X3 in there, and then the code from the PDF example for this, which I cannot select. Okay, so I'll just have to copy it. So we got move 0 to X3. Then it's like move X1. So I'm just gonna move like we have it here. We've got 69 to X2, move 85 to X2, move 72 to X2, and then the output goes into X1, move 2 X3, move X2, X1. Oh, that's just output. So how does that work? That works by so like we're writing there. And what is D0? Does D0 let me change the pointed value? Memory pointers can be read and written over X bus with the A pins. Memory values referenced by pointers can be read and written over the D0. So I think those pointers, so what is D0? So like if I move X2 into the accumulator, what is that going to do? Oh, hello. So we can write those values into there, and then we read it. That doesn't seem to work. Read in reverse. Move 2 to x3. Oh. Oh, I see. This is like... Boy. Move to x3, right? So that should change where we point to. Yeah, that changes. That's the address. We set the address with D. And then we read and write. I assume we can get the current address. So we could say like move x3 to accumulator, sub move accumulator to x3. Like we could do something a little dynamic like that. So that's going to give us, we got our values in. We're at pointer 3. We move up. Yeah, so we can read the pointer location. We can write the pointer location. We can read and write the value at the pointed location, and that will advance the pointer. Low-level machines, am I right? Okay, so we have to click and hold this button. There's no way for us to verify this, so we're trusting you. I mean, I made a thing that does the thing. I mean, I'd like to make a one, but I don't have an idea. And like making the graphics, that's just it's just a 2D image basically with some black segments. Make like those simple little, clicker games. I don't think they're that common anymore. If you're my age, you definitely know what they are. Let's see. I want to talk about goofy things visitors here tend to say. I thought China was communist, so why is everybody shopping at a store? What is up with that? And that's when everybody around laughs because, one, the dude always thinks he's making some good observation. And two, gosh, it's complicated. So many of these guys in present communist China still come right out of the 1970s. Yeah, okay. Wireless game controller. Create a working design for this product. I think I'm stuck in because of Kaizen took place in the 80s and Exapunks was kind of in the past a little bit. And then, of course, I just watched the latest Stranger Things, so I'm stuck in the mindset of 80s. So all this wireless self-driving cars feels out of place in here. But anyways, wrapping up a project to make a game console. Wow, just make a game console. Yeah, cool. Yeah, let's do it. Let's make a wireless controller for your game console. So we've got our transmitter. X and Y are simple inputs connected to a joystick. A and B are simple inputs connected to the buttons. Radio RX is a non-blocking X bus input connected to a radio receiver. TX connected to the transmitter. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure to use the most recent input values. So X, Y, 0 if A, okay, so 0, 1, 2, or 3. So what is, X, Y, and then 0, 1, 2, or 3. Okay. So that's what we want to do. The latest input values, that's probably going to get us, right? So X comes in here. 63, 37. Okay, no, I think we can just read it. And then 0. Because these are both on. So yeah, I think we just need to read basically do some math. I don't think we can get away with this. We're always going to start with this little one. So yeah, so when we read, oh, we got quite a few bits here to go through. So yeah, we're gonna need at least a couple. So you need to be wired to P0, and then we're gonna wire this one to P1. Why did I go over that? Okay. So what we're gonna do here is we're just gonna copy the two values out, so they get written always. So I guess x1 will ask us for a value. So I guess we'll sleep until x1 asks us for a value. And then we'll just move that value. I don't think we can move it. We have to read it, right? So we'll move it to the accumulator because we're not really going to use the accumulator. We're going to move P0 to x1. We're going to move P1 to x1. So we'll move both of those. So it's x and y, which is the order that we need to do it in. Okay, so we got the x and y taken care of. We need the inputs here. So A is going to go in there, B is going to go in there, and our inputs are the confusing part. So if A is 0, so we're going to move 0. Okay, we're going to sleep x0. Move x0 into the accumulator. So that could be our 0. We're going to test equal A P0 is 100. If it's 100, we're going to add 1. We're going to test if stink. No, we can't do that. Oh, wait. A. Yeah. Okay. Because if A is 100, that's 1. If B is 100 and A is 0, that's 2. If A is 100 and B is 100, that's 3, which is 1 plus 2. So yeah, okay. So we can do what I was going to do. I was going to add 1 here. And then if B is pressed, we're going to add 2. That's a plus. We need a plus there. And then we're going to move the accumulator to x0. And then we'll sleep until that's done. So then you will be sitting there. Oh, how do I wire this all up? You will be sitting there waiting for all of these signals. I think I need to move some peeps around. So you go there. You go there. Let's move you up there. So I don't need P, but I do need X. So those need to receive. I don't need that P, but we are going to need to move. We're going to need to move this controller like over here, I guess. Or you can go up to P0. There we go. And you will go there. Okay. Perfect. Because then I can put a bridge right there. So that can go. So that can go to x0. And you can go to x1. That is a lot. That is a lot. So when we receive a -1, so we're gonna test equal Rx -1. It's not Rx. It's x2. So when x2 is -1, we're basically going to do all of our stuff. We are going to get our... Yeah, we're going to move 0 to x0. Then we're going to move x0 to x3, move x0 to x3. We're going to move 0 to x1. I think I can like move 0 to x1, right? Get those both kind of started, and then we can move x1 to x3. And then we can sleep 1. Right, so let's step through here. So I should get, so I send that off. Okay, so what I'm thinking is I'm going to swap these signals because that one's more instant. Right, so we go get that one started. We get this one started. Then we write 6337. We got a 0 back. We write that. Okay, yeah. Boom. We're doing it. We are doing it. Best is one line less code, cheaper product, but more power. Interesting. How could I make this cheaper? This one's pretty simple, and it just reads 2 pins. So I think that's probably what we'll end up doing. If we map, well, yeah, so we'll bring you down, basically, so we can make these like parallel, parallel, and we're actually going to get rid of these components. We're going to put you like over there for now. All of these wires can go away. We're going to unwire that for a sec. We're going to come over here. Yeah. You need to go around to X1, right? Yeah, X1. These come through. I think we're going to go... Yeah, we need to like... Because we need 2 bridges. We need a bridge to like get us over there. So we need to like go around that bridge. Wow, the wiring in here is like insanity. It's a good thing wires don't like cost us any money either. So that's always good. And that's needed because we need to put a bridge in here. How do I change the direction of the bridge? Are you kidding me? I can only do up and down bridges? How do I rotate the bridge? Bridge, rotate the bridge. Alright, I guess I don't rotate bridges. So, what do we do here? What do we do here? I need to get the pin inputs in. So, yeah. I don't know where that was going anyways. Alright, so let's get these pin inputs in place. So I do need one bridge here. So we can put that in P0. So yeah, so instead of that command, we'll move P0 to X3, and then we'll move P1 to X3, and then we'll move X1 to X3, X3 is not hooked up to anything. So then you need to go to P0. So if we bridge here, right, that gets us here. And then if we've got that coming through, we just need to bridge over like that. Right, but I can't bridge this way. What I could do is, like, I guess bridge up somewhere so this one could come through. Come through like there, I suppose. So we're going here. Our X, well, actually we can just bring it down, right? So you can go across there like that. Perfect-ish. Perfect. No, that's not perfect. Because I need to get it up here. You know what? I think I'm trying too hard. I've got 2 X buffers over here. Right? So let's do some movement. I already have this logic. I don't need that logic anymore. Not like that logic is hard. Okay. So we put you over here, right? And then that should make it a little easier because we got receive on X0, transmit on X1. X can come into P0, just super simple. You can easily enough well, I can bring them back. Yeah, I can bring it back one. So that creates like there. Then I can put a bridge here. And we can do this maneuver to... Okay, now transmit has been moved from X3 over. We got another ad break coming in 22 minutes. But we should be done streaming by then. So X3 is now X1. X2 is now X0. P0 is still X, and P1 is still Y. X2 to X1, yeah. And we don't need you. Part is connected to self. Right there, okay. All right. Bam. We're immediately dead. Part is not... Oh, why is it blocked? Move. X2. Yeah, there we go. Okay, there we go. There we go. We're down from 11 to 8. Our power has dropped significantly to 262, and our code is now lower than it's ever been. That's great. Perfect results, man. Perfect results. A little help. Thanks, mate. I owe you one. You've just helped me make thousands of dead to tired salarymen marginally happier. Are you lonely? Do you feel isolated and disconnected from the world? Just go to buddybots.friends. Please don't blame me for this. I have a friend, more like an acquaintance really, from a while back. Many jobs goes product laser tag equipment. Cool. Awesome Plex. He's calling his franchise to be the Awesome Plex. A lot of simple inputs, either on or off. Too many for a microcontroller on its own, but a good use for the DX300. Is that what this is? Yes! We're starting to get some stuff. Ooh, we got a couple of things. We got some RAM, too. We got an ammo counter. Goodness gracious. Having flashbacks. I think I've done this in the past, and this is, there's a lot going on here. Okay, so HIT is a simple input connected to an array of laser sensors on a vest. Respawn is a simple input connected to a quick connect jack on a vest. Alive is a simple input connected to an array of LED lights on a vest. Trigger and reload are simple inputs connected to switches in a replica gun. Fire is a simple output connected to a laser and effects module in a replica gun. When a player is hit, their vest should be set to not alive. It's a simple output connected to an LED. When the players respawn, their vest should be set to alive. When a player reloads their gun, whether alive or not, their ammo count should be set to the ammo reload value. When a player is alive, pulls the trigger, and has ammo remaining, the gun should fire, and the ammo count should be decremented by 1. To allow for realistic operation of various replica guns, the ammo reload value is set by the operator using a dial that can be read as an X-bus input. Alright, so that's our ammo value. So I guess once it initializes, we need to load in like ammo count and alive. So this is our data. Probably want to go this way because that's the output, and then we can set the values going in. We've got a lot of things to track here. Alive does need to be read, so we do need a controller specifically for alive, right? So like this controller is specifically for alive. Pin type mismatch, of course, right? So alive goes there. X1 goes there. Pin type mismatch, really? So I guess we'll move you over there. So basically, I guess we'll use, we'll move P2 into the accumulator. It's P1, isn't it? It's not P2. Where did I get P2 from? I guess I was looking over here. P1, yeah. P1 into the accumulator. We're going to take digit, was it 1, 2, 3, right? Because it goes from the right-hand side. So we're going to take digit 3. We're going to mul 100. And we're going to move the accumulator to alive, which is P0. And we're going to sleep for 1. So that should handle our alive bit. So if we advance, we do start off dead and then respawn. When respawn hits, it sets us to alive. So basically, when respawn comes in, right, that's going to set us to alive. So we're going to test equal respawn, right, which is P0 100. When that hits 100, we are going to move 100. I guess we want to read. We got to read it. We got to read it out. Crud. Where's my bridge? Yeah, because I got to read it. I gotta read it. I gotta move P0 into the accumulator because we're gonna have other values. What else are we tracking other than alive? We've got ammo count and alive. Ammo count and alive, really. So we need to track ammo count anyways. This is 2. And I think with this, we don't need... this one's harder to set because we've got to go through. We got to read it. I mean, multiple things can go in there. I think we got this. So I would think I'm going to prefer this one, actually. Oh, but only one thing can read it at a time because we've got to set the pointer from this direction or this direction. Oof. What is going to be setting alive? This is going to be reading alive. This is going to be setting alive. So I guess if like setting is coming in here, but no. No. Okay, we're going to put that in there. Pin type mismatch because we need to flip it around. Yeah, so we're gonna pull it in. We're gonna digit set 3 to 1 because it's respawn, right? So they respawned, and then we're gonna move accumulator to X1. So we're gonna set it, and then we just sleep. We just sleep one. Right, and then when hit comes in, we die. But we already have our 2 pins taken care of, so that sucks. We can have like a translation unit that's like here. This one could actually read from hit, and then if we move you over there temporarily, we could have respawn come in here like that. So we could do a hit or a respawn, and we could write that out here. So we move you over here, and we erase this stuff. We may not need the bridge. We'll see. Oh, we do need the bridge there. Yeah, we need the bridge there. Yeah, so we can get that out. So we actually need the bridge there. Okay, all right. So this is going to be simpler. We're going to do, I guess we're going to do one of 3 values, right? So we're going to, if we're hit, we're going to move. So test equal P0. If that's 100, then we're going to move 1 to X1. If P1 is 100, do we ever get hit? Do we ever get hit and respawn? We never get hit and respawn at the same time. If that's 100, we're going to move 2 to X1. And then we're just going to sleep 1. Okay, so that's our main loop. So now this one can change. We're reading in an X here. We can just run that there. But we do need to bring that in. So we need another bridge, I suppose. So this one's going to handle, so we're gonna sleep X, SLX, X0, move X0 into the accumulator, test equal X0 if it's equal to 1. Then we need to yeah. Move, SLX X0, move X0 to the accumulator. If it's equal to 1, if accumulator is equal to 1, 1 is a hit, 2 is a respawn. So if it's equal to 1, we die, which means we move P1 to accumulator, DST 30, and then we test if accumulator 1 is 2, I guess. Then we want to test if it's 2. I really feel like we just have 2 of them both writing to it at the same time, but they both have to read from it too, which is probably fine. We just have them all like on their own, right? So we just do like a hit. Okay. Oh, that's P, yeah. So that goes there, that one goes there. We can simplify this wiring a little bit because we don't need all of that space. We don't need the bridge at the moment. We can pull this up into P1 and we can pull this up into P2. Is that going to be 2 bridges? We can only have 1 bridge. 1 bridge there. And then 1 bridge there. Then our X ones can come out. They will join forces like that, and they'll write into it. Okay, so you only detect... all right, so test is equal 100. P0, if it's equal to 100, then we died. We're gonna move P1 into the accumulator. Move P1 into the accumulator. DST 31. Move the accumulator. X1. And we're sleep 1. And we're basically going to do the exact same thing here. Yep. We're going to do the exact same thing here, except... Oh no, that's hit. So we die. We set that to 0. So that should handle our alive state. That did not handle our alive state. Why did that handle our alive state? Respawn is writing a 0. What? Move P1. P1 in the accumulator. DST. Wait. Why did DST not do anything? DST should have definitely done something. DST should have done a thing. A thing DST should have done. DST RI. Set the digit of accumulator specified by the first operand to the value of the second operand. Yeah, so DST 07. Why isn't that setting anything? DST 012. Oh, 012. Off by 1 error. Very common programming error. Okay, now that... that didn't set us alive. Why didn't that set us alive? Okay, so that's 100. We write 100 in. Alive hasn't changed at all. Alive should have changed. Alive should have changed. Why hasn't alive changed? Alive hasn't changed because we are still off by 1. Alright, so respawn comes in. We're still not alive. Yep. So 0 goes into the accumulator pretty quickly. Yeah. Yeah, 0 goes in pretty quick. But I mean, we should be reading it out. Move P1 into the accumulator. Like, how is that not reading? Hang on a sec. Are you trying to tell me that, like, I have to read the digits themselves? Like, is that what that is? So I'm late on that. That's got to be delayed. That's got to be delayed like several steps, really. Like, it almost needs a signal to read it. I want to say the same signal that writes to the same signal that we use to write to it could be used to signal this to update. This is really only responding to changes. If I didn't need to know if other people were alive elsewhere in the program, then I'd be tempted to do something else. So I think I'm going to turn this around so we don't have to do this like convoluted mess of like, boom. That can go and just right in there. But actually these can go right into the same one. Because what I want to do is I want that to branch off down here. Like that. Now how do I get through the pin through there? Who knows, right? We put that there. That'll get the pin in there. Then we can put this bridge here so we can read the pin. So what are we looking at here? I still don't understand how this works. Maybe I need to read it. Maybe I actually need to read it. Let's... okay, so they are outputting 100. Okay, so in each one of these scenarios, it'll output 100 if it's okay. So we actually don't care. We don't need all this digit stuff, really. Okay, so we're going to sleep X1, right? We're going to move. Well, we actually don't care. Well, that should wake us up. Then we can move P0, which I guess will respond, right? We're writing 1, 0. So 0, 1, 2, I guess. Oh yeah, 0, 1, 2. Yeah, the digits right there. Okay, so we're setting 0. So T equal P0, 100. If that is 100, we don't even need this controller. We do not need this controller at all. We just go straight there. Yeah, we're good. That just goes straight out. Right, so... yeah, so we're alive. Then we get hit. We're dead. We respawn. Okay, we are alive. All right, so reload. We need ammo count. So that's really kind of like what you're here for, I suppose. So, yeah. Where do you need to go? We are going to need to be able to read alive somewhere else. So I need that to be there. I I don't need that. I do need that. Yeah, these do read. Why do they read it? Because I think I have to input. I have to 110. 1011. Yeah, because it writes them all. So, like, I need all of their values, basically. But I'm only using the one value, so I guess I don't care. I don't care. We can get rid of this requirement if I don't care what its current value is. Which probably means I only need one controller here. Because basically, I will need a pin. I mean, I will need a bridge. I prematurely got rid of that bridge. Yeah, so we're going to test equal hit, right? So hit is P0. If that's 100, then we're going to move, we're dead. So we're going to move 0 to X1. Test equal P1, 100. So we respawn. We're going to move 100. So we're going to move 1 to X1. And then we're going to sleep 1, right? So that's really all we need. That should handle the alive status just fine. And it does. It handles the alive status, which is exactly what we need it to do. So I think we can probably move you back. That just gives us some more working room. Yeah. All right. So we kind of reduced that as much as we could. Actually, no, I think we've reduced that like as much as we can. Yeah, so we've got alive, we've got reload. So reload really just needs to go in like somewhere over here. Let's put reload like over here, right? So you will probably just need to go into X, right? Yeah. I'm gonna wire you. So pen type mismatch, of course. We just need the X version. Then we just need the X version. Oh no, because it's got to receive a pen input. It needs a pen input. It needs a pen input. Crud. That's you. So you need 2 X's. You can't write to memory. Well, yeah, you're fine. So we got X2 and X3. So ammo count's just going to be 0. And then we'll receive, if we receive a reload here, something happened. Ad break finished. Sorry, I'm just kind of plowing right through that. I'm going to try to finish this one. So this is the reload trigger. All right, so we're basically going to test, like, if not, we're going to test equal P1. If that's 100, so if we hit reload, we're going to move 0 to X2. That'll put us, you know what? We'll assume that we're on there. We'll assume that we're on there, and we're going to move X1 to X3. We're going to write that onto the pointer value, and then we will move 0 to X2. So that'll reset us back. And that's pretty much that. Like, it just needs 3 X's and a pin. So that sucks. That sucks. I mean, I could probably No, it's fine. It just sucks. That's all. Yeah. So we're gonna step through. What is that? Oh, we need to sleep, don't we? Sleep 1. Yeah. Oh, why are we constantly writing move 0 to x2? Why is that advancing the pointer every time? Okay, hang on a sec. Where are we at? We're simulate. No, we don't want to simulate. We want to advance here. Wait. What's going on? Right? So that's 100. So move x1 to x3. Do I have it wrong? Is A? I think I have it wrong. X2. Like address and data, is that how I'm supposed to think about it? Yeah, that's got to be it. I think it's wasteful. We'll just reset it that way. So that sets our ammo. Okay, now we've got when a player is alive, pulls the trigger, and has ammo remaining, the gun should fire, and the ammo count should be decremented by 1, which should go to fire. So then we do have a lot of things to test. So I'm going to pop this up here. We will pull pin 0 into pin there. We do need to write into our data, and we need to... we need multiple pins. Pins are us. You know what I'm saying? Pins are us. I swear. Okay, so bam. What is our cost at? Our cost is 19 yuan. Yuan? But now I don't have enough room here for this thing. Gotta be kidding me. Oh, I hate these pin layouts, I swear. So I need to know if we're alive and if the trigger's pulled. And those both take pin inputs. Then I also need ammo data. How am I going to get ammo data in there and talk to this thing at the same time? Like, the answer is I can't do all of that. Which means I've got too much stuff going on. I could bring this back 1. That pin is still coming from quite a ways away. I could probably reduce this space. I don't really need it. This is unnecessarily close because then nothing else is going to modify alive. You could probably benefit by coming over this way some. We don't need all the wires there. The trigger will come in there. We got P0. We need to read and write the pointer though. So we actually do probably need some space. So I think if we bridge here and here, then we can link that up to the data port. And then we can bring that one up here into our X2, which leaves you available. X3 can come down into X3, and you can go in a pin. Hey! We did it! We did it! Now we just have to implement them. So this is going to sleep X0, and then it's going to move 100 to P1. That's like it. Done. Like that whole thing is coded. Pin is not connected. Pin is not connected. Oh, I do need wires there. Okay. Okay, so this one is doing all of the work, basically. So we're gonna test equal trigger, right? Trigger is P1. If that is 100, we need to know if the player is alive. Test equal P0 100. If the player's alive, if they have ammo. So yeah. So we're gonna move P0 to dat. I guess if we're not, then we're just gonna we'll just jump, skip, and then we'll put this here where we'll sleep one. Yeah, so we can do all the other stuff that we need to do, because we need to do move 0 into the accumulator and test equal P0 100. So if that's 100, we're alive. So we're gonna add 1. We need to check ammo, so we need to move 0 into address, so X2, and then we need to move, or then we need to test equal D1 is X1, is that GT 0, is it greater than 0? We don't have a greater than or equal to. Yeah, so greater than 0. If it's greater than 0, we're gonna move. We're gonna add 1, and then we're running out of space. Oh, that's it. That's it. If we're alive and we have ammo, then we're gonna test equal accumulator if it's 3. Or 2, actually. Those 2 conditions. Then we will move 0x2. I've got to copy it and subtract 1 from it. Jeez. This is a struggle now because I got to bring it through here. Yeah, I got to get the firing through there. I'm wondering if I move you over here. Right? What can I do? What does that give me? It needs to be wired up there, which sucks. If I remove all of this stuff here, we're housekeeping. I mean, we got it all to fit, which was nice. I hate that I'm undoing all of that, but we'll see. We'll see how it plays out. Pull you down here for now. Let's get rid of some of these wires that we don't need just at the moment. So you will go there, and then you need to be wired up to X1. And then they need to be wired to something. Actually, look at... Oh no, we can pull you down, even. Yes, which is great because we can put you there. Yes, connect to something, I guess. I don't know. Now you can go to the memory unit. The memory unit here just needs, yeah, so D1 and A1, X0 and X1. That's like, but I need more room over there. We're gonna write the code like this first. So if it's equal to 100, if P1 is equal to 100, move X2 to X0, and then move 0 to X1, and then sleep 1. Okay, so like that one's like done. So now I can trim the wires and move that over. This I need the pin. Oh yeah, perfect. This can come here. Not perfect. Very unperfect. That's very unperfect, man. I tell you what. Because like I need to get the ammo count out now. So I need the data values. But like that needs to be a pin input. And I need trigger to come into pin. So do I need a room? What do I need? What do I need? If I move these up. What can that give me? Trigger can't come down. So they'd have to go this way. Which is a problem because that's too tight. Oh, I can do that. Right. So trigger can go down now. But reload can't go up. Yeah, that's not going to work there. So if I move this over here, basically, and we put that in pin 1, I guess what we do like this. So P1, we're going to move X1, X0 to something. I need to get the data in here. But I need one of these X's to escape. So like, do I need you there? I don't have enough pieces. Do I need to put you back over this way? Probably. Where do you go so that I can write to you and read to you? This one's already doing a lot. This one isn't doing much of anything. It's really just listening for P1. So I'm wondering if it's listening for the two signals, because I only need, yeah, so if this one listens for the signals, then we should be okay, because trigger can go into P1 and reload can go into P0. But we need space. We need some space. Like if we put U there and X3, we've got 2 X's that can come out and 1 X that can come out this way. So we put a bridge in here. We can get 1 X down there. And then I guess what we want to do is we kind of need that X to come down. So if this is over here, which is the absolute bare, actually we don't need that. We could come into P1. And then it could read no, can't do that. That needs to come in. That can't come in there. I still need 3 exports on it. I need 3 exports on it. Firing is just a signal, right? So if this isn't testing for that, let's see what that looks like. So we're testing P1, which is trigger. So we want to test P2. It's not P2, it's P0. Test P0. If it's P0, we're going to fire. So we're going to move 0 over X0, I guess. Or X2. X2. Like, how am I going to get that in there? X3 can go there. That can bridge. I don't need anything coming into P1. I can do P0. We're going to SLX X0. I can't. And then what are my 2 X's to write out? Oh, it's X2. I already got X2. Okay. But then how do I get this data down here? I don't, do I? Unless I move this. Unless I move this. If I move this, where can I move this? I can move this like here. Not there. So I can move it here. Yeah. That can bring the X down. That can bring that, but then the pin's stuck. Then the pin is stuck. If we do that, 0's at the top. I can't get the pin out. That lets me get the pin out. There's a lot of space in here that's kind of wasted. If I just have a live run there, could I cram you in here maybe? Like you could fit there, I guess. No? Could you fit there? You can't fit there. And I can't wire it that way. So like you are really kind of it. Kind of limiting me. Kind of limiting me here. So that just goes there. P0 needs to come like down there. That just needs to go in there. But now I've got all this space that is wasted. And I don't think I gained anything over here. Okay. We're 25 minutes over. We're going to pause it. and we're going to come back to it with a fresh mind. Thanks for joining me today, and I will see you next week. Have a great weekend. Cheers.